Hello everyone. Today I'd like to introduce you to the model of a PIE SAR, Basic SAR. The basic processing model can convert L1A level SLC data into L2 level strings or amplitude data after geocoding and meet the basic processing need of ordinary user for GF3 data. The basic module can convert L1A level SLC data into L2 level strings or amplitude data after geocoding and meet the basic processing needs of ordinary user for GF3 data. The processing interface of software includes loading and displaying model, data importing model, basic SAR, that is the basic SAR model, in-SAR, delay SAR model, polarimetric SAR model, image classification model, and view model. Data input model is used to input our data model. The basic SAR model includes several functions, such as complex data conversion, multi-look, adaptive alerting, geocoding, image clipping, slant to ground distance conversion, and DB image conversion. Data import, multi-look, and geocoding are necessary steps to acquire SAR image in space, and other steps are optional. In order to acquire SAR image in space, data import, multi-look, and geocoding are necessary steps are optional. Today, we are dealing with GF3 data. The processing flow of high-resolution data is as follows. Firstly, multi-look processing of radar SLC data, radar intensity data processing, image registration, adaptive flirting, and geocoding. First, import data. Click on GF3. We choose GF3 strip data import today. Data import. First, load out our data. Which is the parameter file. Then, we output the files we import. Give it a name. We'll load in the processed result. Give it a 2% linear stretch. This is the data we imported. Next, we proceeded with the processing. We convert complex data into intensity amplitude data. The intensity amplitude feature is one of the most important features of SAR image, and ground object information can be extracted based on SAR intensity amplitude images. Therefore, it is necessary to convert the SAR complex data into SAR intensity amplitude data. We choose the complex data conversion function, enter the file, and load the data we just imported from GF3. The parameter type we choose is the amplitude. Because intensity and amplitude are one of the main features of a SAR image, the feature information of ground objects can be extracted. Therefore, we need to convert SAR complex data into SAR intensity and amplitude data. Select the amplitude parameter type. Continue to output. Click OK. We'll load the data converted to magnitude to see. Multi-look. Continue processing. We'll do multi-look processing of data converted from complex data. In order to improve the visual effect of the SAR image and improve the estimation accuracy of backsketching of each pixel, multi-looking processing is required. The main purpose of multi-look processing is to improve the visual effect of the image and to improve the estimation accuracy of backscattering of each pixel, that is, to average stack multi-independent samples of the target. On the one hand, multi-view processing makes the geometric features of the image closer to the actual situation of the ground. On the other hand, it also reduces spectral noise to a certain extent. Reducing noise while reducing the spectral resolution of the image. The input file selects our data input file. Multi-load parameters can be defined as the default distance and azimuth views. Then we can name the file by clicking on the output. Then we can click on Save and then click on Confirm to do multi-look. We will load the multi-look data into software. After multi-look processing, spectral noise is the inherent failure of SAR image because SAR system is a coherent system. The presence of spectral noise seriously affects the interpretability of SAR images. Since the SAR system is coherent, spectral noise is an inherent phenomenon of a SAR image. The presence of spectral noise seriously affects the interpretability of SAR images. Therefore, spectral noise filtering is needed. The common SAR flaws. Therefore, the spectral noise filtering is needed. The common SAR filters are leaf filters, forced filters, current filters, and so on. The quant filters is chosen for the filtering we are going to perform, and we will load in the data that have completed multi-look. We choose the default window size. The window size is mainly used to set the size of quant filter window. The number of views is mainly to set the number of observations. The variance of noisy is calculated by the number of observations. We output file. Click save and click OK. Quant filtering is performed. We load in the proceed data. SAR geocoding. SAR geocoding. According to the altitude and orbit data download by satellite, the data products of L1 image data after geometric precision, map projection, and resampling are L2 geocoding products. The function of geocoding according to the altitude and orbit data downloaded by satellite, the data products of L1 image data after geometric positioning, map projection, and resampling are L2 geocoding products. Geographic coding is based on RD positioning model, including geographic elliptic correction and geographic terrain correction. The input file selects the quant filtering. The input file selects the quant filter data that has just been completed. We choose elliptic correction for the type of geocoding. We do not choose the local indecent angle. Parameter setting: average elevation 10 meter, output resolution x direction 5 meter, y direction 5 meter. Then the output of the geocoding file is made. Click Save, click OK. Now we are going to do the geocoding. Now that geocoding is over, image clipping. After software provides functions for SAR data such as row and column number clipping. Enter the image we want to clip and select data we have converted into complex numbers. After loading, our image range will automatically display the number of rows currently loaded. We can select a range within clipping range, input the row number of the range, and click OK. It can be clipped. It can be clipped. And to ground conversions. The SAR image in land space is mainly converted to ground distance, and image with a certain spatial resolution is output. The SAR image in sand space is mainly converted to ground distance, and the image with a certain spatial resolution is output. The slant to ground distance conversion function is a distance measured by the radar devices, and the distance measured from the target to the platform, that is, the slant distance. This leads to the distortion of real ground mapping. If the terrain is flat, using our PIE SAR software to correct the oblique ground distance, we can resample the radar image of the oblique distance to the same size as the pixel of the ground distance image. The input software chooses the data filter by queen. We can set the size of pixel and choose 2.5 meters. Select the output file. Click Save. Click OK. Now it is a co-location conversion. Last function, transform to dB image. Because of the poor display effect of intensity image, the image display effect can be enhanced by dB processing. Because of the poor display effect of intensity image, the image display effect can be enhanced by the input file chooses the longitude map after complex data conversion. Select output file. Click Save. Click OK. Transfer dB image. The introduction of PIE SAR basic module is over. Thank you.